This is SpaceTime Series 22, Episode 6. Coming up on SpaceTime, the brightest quasar in the early universe. A new hypothesis suggests the second nearest exoplanet to Earth shouldn't be written off yet as a possible harbour of life. And it's about to happen. Blue Origin are about to begin flying space tourists this year. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers have discovered the brightest object ever seen from a time when the universe was less than 1 billion years old. A report in the astrophysical journal Latest claims this beacon is a quasar, a powerful beam of energy and matter generated by a supermassive black hole as it feeds on infalling material. Quasars are the brightest objects in the universe, shining across the eons of space and time. And this one is no exception. This quasar is an incredible 12.8 billion light-years away, and astronomers were only able to detect it thanks to an effect known as gravitational lensing. First postulated by Albert Einstein, gravitational lensing occurs when the light of a distant object is bent or lensed by the gravitational field of a closer mass, such as a galaxy, located directly between the light source and the observer. The effect amplifies the light of the more distant object, making it easier to see. Astronomers have been searching for these very remote quasars for more than 20 years, but it's taken a rare and fortuitous celestial alignment to make this one visible for them. The study's lead author, Zhai Fan, from the University of Arizona in Tucson, says he doesn't expect to find too many quasars brighter than this discovery in the entire observable universe. Shining with light equivalent to an incredible 600 trillion suns, this super bright quasar, catalogued as J043947.08 plus 163415.7, could hold the record as being the brightest in the early universe for some time, making it a unique object for follow-up studies. You see, the detection provides a rare opportunity to study a zoomed-in image of how black holes accompanied star formation in the very early universe and how they influence the assembly of galaxies. Besides being bright in visible and infrared wavelengths, this lens quasar also shines brilliantly in submillimeter wavelengths, where it was observed using the James Clerk Maxwell Telescope on Mauna Kea in Hawaii. This is due to hot dust heated by intense star formation in the galaxy hosting the lens quasar. In fact, this galaxy's stellar formation rate is expected to be something like 10,000 new stars every year. Now, by comparison, our own galaxy, the Milky Way, is currently producing about 1 solar mass worth of new stars every year. The black hole is not only accreting gas, but it also has a lot of star formation going on around it. But the actual rate of star formation remains uncertain because of the boosting effect of the gravitational lensing. In fact, to be honest, the true rate of star formation could be much lower than the observed brightness suggests. Still, it's a fascinating discovery. You see, the quasar existed during a transitional period in the universe's evolution, known as the epoch of reionization. It's a time when light from the first young stars, galaxies and quasars reheated and reionized the obscuring hydrogen that had cooled off not long after the Big Bang 13.82 billion years ago. This quasar would have gone undetected were it not for the power of the gravitational lensing, which boosted its brightness by a factor of 50. Very distant quasars are usually identified by their red colour. That's due to absorption by all the diffuse gases in the intergalactic space between the origin and the observer, and by the physical expansion of space-time in the universe, causing everything to redshift. The trouble is, sometimes the light from these very early quasars can be contaminated, making it look bluer because of starlight from an intervening galaxy. As a result, they can be overlooked in quasar searches because their colour is diluted to resemble that of a normal nearby galaxy. The authors suggested there could be many other quasars out there that have been missed because of this light contamination. They were lucky to find this quasar because it's so bright, it's drowning out the starlight from the especially faint foreground lensing galaxy. The object was selected by its colour by combining photometric data from the United Kingdom Infrared Telescope Hemisphere Survey, the Panoramic Survey Telescope, and the Rapid Response System, PanSTARRS-1, together with NASA's Wide Field Infrared Survey Explorer archive looking in the mid-infrared ranges. Follow-up spectroscopic observations were then conducted with the University of Arizona's multi-mirror telescope and both the Gemini and Keck observatories in Hawaii. It was these observations which revealed the signature of a very faint foreground galaxy directly between the quasar and Earth, which is magnifying the quasar's image. However, because the source looks, fuzzy in ground-based observations and so could be mistaken for just a galaxy, the authors used NASA's Hubble Space Telescope to confirm that it was in fact a lensed quasar. Fan and colleagues are now analysing a detailed 20-hour spectrum of the quasar, carried out by the European Southern Observatory's Very Large Telescope in Chile. This will help identify the chemical composition and temperatures of intergalactic gas in the early universe. You're listening to Space Time. I'm Stuart Gary. Scientists say Barnard B, an icy super-Earth orbiting Barnard star, could still have the potential to harbour primitive life if it has a large hot iron nickel core and enhanced geothermal activity. Addressing the 233rd meeting of the American Astronomy Society in Seattle, Washington, Villanova University astrophysicist Edward Guinan and Scott Engel claimed geothermal heating could be supporting life zones under Barnard B's surface, akin to the subsurface lakes found here on Earth in Antarctica. Located just 5.9 light-years from Earth, Barnard B is the second nearest known exoplanet to our solar system. Only Proxima b is closer. It orbits the star Proxima Centauri, located 4.2 light-years from Earth. The thing is, Proxima b orbits its host star at a distance of just 7.5 million kilometres, awfully close, taking just 11 Earth days to complete each orbit. And although it is orbiting within Proxima Centauri's habitable zone, its average surface temperature is minus 39 degrees Celsius. And, being so close to its host star, it's subjected to an incredible bombardment of stellar winds and radiation, over 2,000 times stronger than the solar winds which bathe the Earth. Like Proxima Centauri, Barnard's star is a spectral type M red dwarf, smaller and cooler than the Sun. The planet Barnard B, catalogued as GJ699b, orbits its host star every 233 Earth days, and its orbital distance is right on Barnard star's snowline, where surface temperatures are around minus 170 degrees Celsius. The study by Guinan and Engel suggests that while Barnard B would have a very cold environment, it could, theoretically at least, support life. Guinan points out that the exoplanet's surface temperature is very similar to that of Jupiter's icy moon Europa, which thanks to tidal heating has a liquid water ocean under its icy surface. And because of this, Europa is considered a prime candidate for life beyond Earth. Guinan and Engel based their hypothesis on detailed high-precision photometry of Barnard's star, as well as dozens of other stars over the past 15 years. This data, along with that from other observers, was included in a recent study published on the pre-press physics website archive.org. Engel says the most significant aspect of the discovery of Barnard B is that it means the two nearest star systems to the Sun are now both known to host planets. And that finding alone supports previous studies based on Kepler mission data, which infer that planets must be very common throughout the galaxy, even numbering in the tens of billions. Also, Barnard's star is about twice as old as the Sun, around 9 billion years compared to the Sun's 4.6 billion years. Engel says that means the universe has been producing Earth-sized planets far longer than the Sun has existed. It also means that a terrestrial world orbiting another star has had plenty of time to combine the ingredients needed to produce life. You're listening to Space Time. I'm Stuart Gary. "2019 marks the 150th anniversary of the Great Melbourne Telescope, or GMT, one of Australia's earliest mega science endeavours. Built in Dublin by the Grubb Telescope Company, the GMT was the largest steerable telescope in the world at the time of its commissioning at the Melbourne Observatory. The reflector telescope featured a 1.2 metre or 48-inch diameter speculum metallic primary mirror and was equipped with an equatorial mounting, enabling it to track the stars accurately as they appeared to move across the sky. The Great Melbourne Telescope achieved first light in August 1869. The GMT was designed to explore the nebula visible in the southern hemisphere, and in particular to document whether any changes had occurred since they were first charted by John Herschel in 1830 at the Cape of Good Hope. The closure of the Melbourne Observatory in 1944 saw the GMT sold off to the Mount Stromlo Observatory in Canberra, where parts were used to make other more modern telescopes. What was left was modernised, eventually even equipped with CCDs for use in studies into dark matter, with the aim of finding massive compact halo objects or machos, one of the early contenders for dark matter. Unfortunately, the disastrous 2003 Canberra bushfires destroyed the Mount Stromlo Observatory and much of its equipment. The remains of the GMT have since been salvaged from the site and returned to Melbourne, where a dedicated band of volunteers are now working to restore the telescope to its former glory and return it to its original home on the grounds of the Melbourne Observatory. Dr. Nick Lom, Consultant Curator of Astronomy with the Powerhouse Museum Sydney Observatory, says the restoration project's a joint undertaking by Museum Victoria, the Astronomical Society of Victoria and the Melbourne Royal Botanic Gardens.
The Great Melbourne Telescope, set up in Melbourne in 1869. It had arrived from Grubb of Dublin, who made the telescope in November of the previous year, that's November 1868, and then it was put into a building, a very large building with a sliding roof was built for it, and supposedly that was the largest building ever constructed with a sliding roof, and the telescope started observing in August 1869. It was the largest steerable telescope at the time in the world at the time. It had a mirror 48 inches or 1.2 meters in width. It was very unusual. In those days, astronomical observatories, professional astronomical observatories, carried out fairly routine tasks of surveying the positions of stars, looking at occultations of stars or planets, looking at eclipses, and they used relatively small telescopes. So that was a very unusual for a major observatory, major professional observatory, to have a large telescope like the Great Melbourne Telescope. It was used for a while at Melbourne Observatory, eventually sort of started becoming less and less used. One of the problems with the telescope was it was large, a little bit unwieldy, and the reason for that because it has a metal mirror, a specular metal mirror. Modern telescopes use glass mirrors with an aluminium or a silver coating, and that started becoming available just at the time the Great Melbourne Telescope was built. But unfortunately, the people who supervised this construction back in Britain were a committee of elderly astronomers, and they weren't very interested in some newfangled ideas like glass mirrors. So they went with the old and trusted method of a metal mirror. These tarnish very easily, and then when they tarnish, they have to be refigured. Very difficult thing to do.
What do they say? The progression of science can be read on the tombstones of professors?
Yeah, something like that. So unfortunately, they made the wrong decision with this one. So eventually, the telescope became out of use. Then in 1944, when the Melbourne Observatory was closed down, it was sold to Mount Stromlo Observatory in Canberra. Then it had a revival, had a new life at Stromlo. It was rebuilt initially as one telescope, one modern telescope. Then later on, it was rebuilt to look at machos. It was an automated telescope by then to look at machos, which stands for Massive Astrophysical Compact Halo Objects.
Yeah, these were one of the two leading candidates for dark matter years and years ago, before we fully understood cold dark matter. WIMPs were the other one, weakly interactive massive particles.
That's right. So that was a sort of carefully constructed acronym to contrast with WIMPs, which was the other candidate for dark matter.
And the more we look, the more convinced scientists now are that dark matter can't be machos. There just aren't enough black holes and things like that in the universe to account for it.
That's right. The telescope did not really find enough to be a significant component of dark matter. I think it did find some, but certainly not enough to be a significant part of dark matter. So I think we're back with called dark matter for our current ideas of dark matter. But the telescope operated very nicely until 2003, when in January 2003, unfortunately, we had the Mount Stromlo fire, and the telescope, with quite a number of other telescopes at Mount Stromlo Observatory, was burnt down, and it looked very, very sad in the sort of short period afterwards, and I saw it a year out later. It was just a hunk. But the parts have been rescued and they've been brought back to Melbourne, and they've been reunited with other parts that are already held by the Museum Victoria. and the telescope is being put together. There's a team of volunteers who've been working on it very hard for a number of years, a number of volunteers, and these are members of the Astronomy Society Victoria, and they've been working at restoring the telescope. They've been cleaning up the parts, they've been working out what parts are missing, they've been undoing the changes that Astronomy Observatory did to put up their version of the telescope, and they really plan to have the telescope put back together and eventually put back in its original location at Melbourne Observatory. That building where it used to be still exists.
Oh, wow.
Yeah, it still needs a lot of work, but the original building still exists and there's still a roof, so eventually that can all come together.
It's all there in the Australasian Sky Guide for 2019. Where can people get the book?
The book is available through major bookstores. It's also available for people in Sydney directly from Museum of Applied Arts and Sciences, the Powerhouse Museum, which is what publishes the book, or also from Sydney Observatory. The cost is only $16.95, so it's not expensive, especially for younger people, just to try and get them interested in astronomy, space. It's written for people without a background in astronomy, so there's no prior knowledge needed to be able to use the book.
That's Dr. Nick Lom, Consultant Curator of Astronomy at the Powerhouse Museum, Sydney Observatory. And this is Space Time. I'm Stuart Gary. Blue Origin boss and Amazon founder Jeff Bezos says the company will begin flying tourists into space this year, although he admits tickets haven't gone on sale just yet. Reports suggest the company plans on charging somewhere between $200,000 and $300,000 per seat, although that final figure will probably depend on how much rival Virgin Galactic decides to charge space tourists for their suborbital flights once it begins services. To get its tourists into space, Blue Origin is offering an 18-metre tall suborbital spacecraft called the New Shepard, named after Alan Shepard, the first American in space. Unlike Virgin Galactic's spaceplane, which takes off and lands horizontally, New Shepard is a suborbital vertical takeoff and landing spacecraft, comprising a conventional liquid hydrogen and liquid oxygen fueled booster, known as a propulsion module, and a pressurized passenger or crew capsule designed to carry up to 6 people on ballistic flights to over 100 kilometres or 328,000 feet in altitude, the official start of space. The rocket is blasted into space from a conventional launch pad, firing its main engine for approximately 110 seconds, enough to accelerate the spacecraft to an altitude of 40 kilometres or 130,000 feet, where MECO or main engine cutout and stage separation occur. The booster then returns to the launch site for a powered vertical landing, followed by servicing for the next launch. Meanwhile, the capsule's momentum continues to carry it upwards in an unpowered flight, culminating in an apogee altitude of just over 100 kilometres. Space tourists are then treated to a few minutes of microgravity, as well as spectacular views of the Earth from space through giant panoramic picture view windows, before the capsule begins to re-enter the atmosphere. As it falls back to Earth, the capsule deploys a series of parachutes, allowing it to gently float towards the ground. And finally, seconds before touchdown, solid rocket descent engines are fired to provide a soft landing. The total mission duration time, from launch to landing, is planned to be around 10 minutes. Blue Origin want to build at least 10 spacecraft, flying about once a week from their West Texas launch facility. As well as space tourism, the company is also pushing New Shepard for scientific payloads, with several test flights already carrying research experiments. So far, 9 test flights have been carried out. A 10th test flight, slated for last month, was scrubbed due to technical issues. It's now been rescheduled for sometime early this year. And time now to take a brief look at some of the other stories making news in science this week with a Science Report. A new study has found that getting more than the recommended 6 to 8 hours of sleep a night has been linked to a higher risk of developing cardiovascular disease and death. The findings, reported in the European Heart Journal, suggest that oversleeping could increase your heart risk by as much as 41%. Those who didn't get enough sleep also had a 9% higher risk, although this finding wasn't statistically significant. The study, however, could not show that abnormal sleeping patterns actually cause cardiovascular disease, but rather that oversleeping may be a sign of an underlying condition which itself increases the risk. A new study warns that teens who say they've only smoked cannabis once or twice have both structural and cognitive changes in their brains compared to teens who have never smoked weed. The findings, reported in the journal Neurosci, are based on brain scans of 46 14-year-old kids. Scientists found a greater volume of grey matter in some brain regions among teens with just 1 or 2 instances of cannabis use compared to those who had never tried dope. The researchers also found a link between these changes in grey matter and assessments of reasoning and anxiety. A new study shows that bacteria stranded aboard the International Space Station is adapting to survive. The study, by scientists at Northwestern University, found that despite its seemingly harsh conditions, the space station environment is not causing bacteria to mutate into dangerous antibiotic-resistant superbugs. While bacteria isolated in swabs taken from surfaces aboard the ISS did contain different genes compared to their Earthling counterparts, those genes did not make the bacteria more detrimental to human health. Scientists say the bacteria are instead simply responding and perhaps evolving to survive in a stressful environment. The study follows speculation about radiation, microgravity, and the lack of ventilation aboard the space station and how that might affect living organisms, including bacteria, in orbit. The space station houses thousands of different microbes, which have travelled into space stowing away on astronauts or in cargo. Scientists compared strains of Staphylococcus aureus and Bacillus cereus on the space station to those found on Earth. Staphylococcus aureus, which is found on human skin, contains the tough-to-treat MSRA strain. On the other hand, Bacillus cereus lives in soil and has fewer implications for human health. Bacteria on human skin are very happy there, living in warm, oily conditions surrounded by lots of organic chemicals. But when people shed those bacteria, the bugs find themselves in a very different environment, cold and barren, which can be extremely stressful for some bacteria. To adapt, the bacteria containing advantageous genes are selected for, or they mutate. Based on genomic analysis, it looks like the bacteria on the space station are adapting to live and not evolving to cause disease. And finally for now, a new study claims female budgerigars, which are known as parakeets in the US, appear to find clever male budgies especially attractive. The findings, reported in the journal Science, are based on observations of clever behaviour, such as the ability to solve problems to gain access to food. It shows that being a clever bird can affect mate preferences in birds, making especially adept males the preferred mates of females. And that's a behaviour which could underlie the evolution of cognitive performance in all non-human animals. Researchers looked to see whether female budgies altered their preference for males after observing a potential suitor's ability to open a puzzle box and access the food within. In a series of trials, female birds were paired with 2 males from which she chose a preferred partner. Then, outside the view of the female, the non-preferred male was trained to open boxes of food. Scientists found that after the female watched the trained bird successfully open boxes and retrieve food, and observed her non-trained chosen partner fail to do the same, the female shifted their preference to the previously non-preferred but apparently cleverer males. You're listening to SpaceTime. I'm Stuart Gary, and that's the show for now. You can subscribe and download SpaceTime as a free twice-weekly podcast through Apple Podcast iTunes, Stitcher, Bytes.com, Pocket Casts, SoundCloud, YouTube, Audio Boom, from spacetimewithstuartgary.com, or from your favourite podcast download provider. SpaceTime's also broadcast coast to coast across the United States on Science 360 Radio by the National Science Foundation in Washington, D.C., and available around the world on TuneIn Radio. If you want more SpaceTime, check out our blog where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us on Twitter through @StuartGary, at Spacetime with Stuart Gary on Instagram, and on Facebook, just go to www.facebook.com/Spacetime with Stuart Gary. Spacetime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to Spacetime with Stuart Gary. This has been another quality podcast production from Bytes.com.